Hi, good morning, afternoon, evening, whenever you're watching this. I'm not going to lie, I love this little snap camera. Ooh, it's made my heart leap. Well, today, what we've got going on is we're going to do a lesson on something called absolute value. And I think this is going to be completely new for everybody. Here's a couple seconds. Actually, you don't get my time. If you need to correct your homework, you can stop the video, right? And start it right back up again. So this is a journal and the book you're going to do today. I have it out of order. Sorry about that. Here we go. These are the pages in your book. There's a lot, but there really isn't that much for you to do. It's mostly just take a look because this is a new concept. There are 5 practice problems. They are all odd numbered so that you can check them in the back. Your journal page looks just like this. And this is the Google Doc, which we made to look exactly like that. So you can get on to this Google Doc, type everything in, submit it by class time tomorrow. So our goal today is to learn about absolute value. It's a little weird, but it really is easy enough. So there's a link for you in Classroom. If you haven't gotten that ready, you should stop me and go ahead and do that. And if you have, super, I'm going to keep going. So what you get when you go to this link is this little jumping flea. And my slides actually have some directions, so I'm going to make sure I can read them. It says if the flea starts at 1, and I'm going to put him there. If the flea starts at 1 and he jumps 4 units to the right, so where does he end up, right? Y'all know that if he jumps, and I can use this little slider up here, I can make him jump 4 units to the right. Bang, he jumps. Oh, it's magic. And there he is at the 5. And how far away from 0 is he? Well, you guys know he's 5 units away, right? Okay. If he starts back at 1, where we had him, and now he jumps 4 units to the left, question is, where does he end up? Notice he turned around. So cute. You know where he's going to end up? Boom. He's going to end up on -3, right? And now, how many units away from 0 is he? Well, he's 3. Okay. But if I take this guy and I put him at 0, come here, little dude, and I put him at 0, and now I have him jump 4 units to the left, you know where he's going to end up? 4. And if I put him back on 0, and now I have him jump 4 units to the right, where does he end up? And my question is for you to think about, which time is he farther from 0? And I hope you realize neither, right? He's the same. He's 4 hops this way, or he's 4 hops that way. If I do the same thing, and now I put him back at 0, and I have him jump 7, right? If I have 7 to the right, you know where he'll end up. Ah, that guy can jump, huh? Or I put him here, and I have him jump 7 units to the left. We still, no matter which way, he's 7 units away. I know he's at -7, but he's not -7 units away, right? So that's for you to think about. All right. If I told you now that my guy started at 0 and he ended up jumping 2 units, there are 2 places he could end up. Think about where they would be. So he's going to jump 2 units. Well, I'm going to go right back here for a minute and tell you he's at 0, and I could have him jump 2 units to the left, and he'd be at -2. Or I could have him jump 2 units to the right, and he'd be at +2. That's something you'll need to be thinking about. All right. So what we're talking about today is the absolute value. And what that absolute value is that distance from 0. Just a second or two ago, I showed you that Flea, he was 4 units away from 0. Once on the negative side, once on the positive time. And regardless, we knew he was 4 hops away. So the absolute value is that distance. And it doesn't matter whether it's to the left of 0 or to the right of 0, because both times it's a 4-unit jump. And when we did 7, 7 to the right of 0, 7 to the left of 0, and it was a 7-unit jump. So absolute value, we actually use these straight up and down bars, these vertical bars, and we read this, the absolute value of -4. And what is the absolute value of -4? This is going to shock you. What it's meant to show is how many hops. Well, the answer is 4. It's 4 hops. So absolute value is always comes out of those guys as a positive number. That's a thing, because when you talk about going distances, you never say, oh yeah, I walked -2 blocks to my friend's house. Even if you walked it backwards, you didn't walk -2. And these bars, these vertical bars that we draw around your number, they work like parentheses, and they follow the same rule as parentheses. Like when you're using PEMDAS rules, the only exception is that everything that comes out of those parentheses is positive. Stick that in your brain. So if the bug is to the left of 0 and the absolute value of its location is 5, where on the number line is it? Think about it. It'd be at -5. But the absolute value of -5 is still 5. It's 5 jumps away from 0. If the bug is to the right of 0 and the absolute value of its location is 2.5, so there it is. Where on the number line is it? It's at 2.5. So positive numbers come out. If positive numbers are inside, positive numbers come out. If negative numbers are inside, positive numbers come out. So I'd like you to take a second with your materials and try to order these numbers from least to greatest, 1, 3, and 6. Ooh, this is a brain teaser. Kidding. Right there they are. So now we've got the absolute value of 1 and the absolute value of 3 and the absolute value of 6 from least to greatest. And it's the same. That should make sense to you, I hope. These are all positive anyway, and out they come positive. But now I've got -1, -3, and -6. This is that stop the video time. Give it a try. Order them from least to greatest. You should have this, right? Because the smallest is -6. It's going to be way over here on that number line when 0's here. And -1's going to be there. You get it. So now you have to order the absolute value of 1, the absolute value of 3, and the absolute value of 6. Give that some thought. It's not quite as simple as you think. And look what happens. Because why? This guy becomes positive, and this guy becomes positive, and this guy becomes positive, and then in order, there they are. So what do you notice about the absolute value, right? It's going to change things if they're negative. -10, the absolute value of -10, which seems like, I don't know, I owe money, is really 10. Saying, oh, I walked backwards 10 steps. How far did I get? You got 10. So if I run a mile race heading towards Menards, and Mrs. Digman runs a mile race against me heading towards Pizza Hut, the question is who runs farther? And I'm not asking faster. I know she's going to beat me. So I'm going to go that way 1 mile. She's going to go that way 1 mile. Who runs farther? Neither of us. We both run 1 mile. It's the same distance. And that's how absolute value works, because we're measuring distances. Okay, kiddos, the absolute value is the distance of a number from 0 on the number line, regardless of direction. So the absolute value of 10 and -10, it's the same. It's 10. And my mile and Mrs. Digman's mile is the same because we're both starting at 0, our starting point. All right, grab your materials for writing. Tell me the absolute value of -28. And what is it? It's 28. If I took that distance, what's the absolute value of 56? It's 56. Only positive numbers come out. What's the absolute value of 8? I'm sorry, of negative 8? What? It's 8. But what other number could have an absolute value of 8? What else could I have put in here that would come out and equal 8? Well, positive 8, right? Positive numbers come out and stay positive. Negative numbers come out and become positive. So this one's tricky. I hope you're thinking. I'm going to do it in 2 steps. What comes out of these guys? Well, 3 does. And see that opposite sign? It's been waiting for the absolute value parentheses to go away. It's been lurking and stalking. And the minute this guy shows up, he's like, aha, got ya. And he's negative. All right, some math to do. What do you want to do is treat these guys like parentheses, right? So if I had this in an equation, I would have to do 3 minus 4 or 3 plus negative 4. Answer to that is negative 1, but because of the absolute value, the answer is positive 1. All right, here's my parentheses. I know they're the absolute value bars. 8 minus 5, you all know the answer to that. The answer is 3, right? And what comes out? 3. Because everything comes out positively, even if it's positive already. I've got 10 plus negative 13, minus negative 13 plus a negative. I have a lot more worms than spiders. How many more? Oop, that's not going to work. Negative 3, but what comes out of absolute value bars is 3. All right, recap. We use that notation to say the absolute value of negative 2, which means the distance of negative 2 from 0 on the number line. That you're there at 0, you're hopping 1 jump, 2 jumps. And that's why it comes out as a positive 2. What does the absolute value of 7 mean? And what is its value? I hope you know that its value is 7. And what it means is 7 hops to the left of 0. What does the absolute value of 1.8 mean? It means 1.8. And it means that if you were on a number line, here's my 0, you've hopped, well, let's say 2 would be right like there, right? You'd hop 1 8/10 distance. All those distances are expressed positively. Well, that's about it, guys. So what should you do? You should read the textbook and do the 5 practice problems. They're listed right there. I think this is new enough that you guys should take a quick look at it. There's some pictures that'll help support you. Then you should do journal page 142. There are 10 problems, same documents for you there on Classroom. You can watch a video if you think it would help, and you should do the practice review page on decimals. All right, that's all I got. See you later.